Now we are live, seems like.
Hey.
So hi, Markus. And
Hi,
I think I never met you in person.
No, I think
and
so
we are
far
both
not.
from Munich. And we have almost identical last name. So your name is Biel.
Yeah.
My name is a little bit better, Bean. So it's compatible with Java Beans. You know, Java Beals. And are you a freelancer? So what?
Yes, I'm well, freelancer, like working as a company, but independent. Yes.
Hey, cool, nice. So we have something else in common. So perfect. So what I would like to do today. So now share your screen and show us a little bit of Quarkus, right?
So first of all, to start this, I would be interested like where everyone is coming from. Well, I'm from Munich, you're from Munich, so maybe you can type in the chat where you're from, right? So we get this a bit started. Coffee Java Beans.
Caesar,
yes.
Where are you from? Kenneth, Diego. Oh, Kenneth already confuses
Brazil,
us.
yes. Buenos Aires, great.
Brazil.
Mexico, Paris, UK, Brazil.
Slovenia
wow.
is nice.
Quito, oh, awesome. I have been in Quito last year. Really nice there. Indiana. Wow, Ukraine, Poland. Whoa, now I really asked for it and the chat is exploding. Okay, wow. So great to have you all here.
Hey, we will break the chat.
Okay, so I guess I can get started with my presentation. I'll share my screen. Okay, we'll have some nice live coding here. Unfortunately, Adam, I'm sorry, I do have a few slides, not too many, and I will do some live coding also, right? So I hope you will not be too disappointed with me.
No, okay. I mean, you have a company, so you need slides.
Okay, yeah, sure, exactly, yeah. So let me hide this guy here. Can you see this nicely?
Yes.
Okay, great. So let's start. So my name is Markus Biel, as we already said. By the way, down here, I hope you can see the link, bit.ly JakartaOne. You will find the slides right now. So if you like, you can go there. You can follow my slides also live. And here in the left, if this goes, if this goes small, Clean Code Academy, there you'll find my free book that you can download if you like, totally free for you. Okay, so now I want to start first of all with having a questions to all of you. Can someone tell me when Java 1.0 was released? I mean, today we have 2019, and that was a long time. Some of you might not even have been born at the time. I mean, I'm currently on full screen, but Adam agreed he's so nice, he'll read this out to me. So maybe you can type in the chat when you think Java 1.0 was released. And there are different dates available because it depends. If we're
so we have, my suggestion
version.
was 1946. Daniel says 83, 2000, 1995, 1994, 1991, 95, 94, 95.
Wow, that's a lot. Okay.
1998, 1918.
So, I saw many times on Twitter people would say it is 1995. I would disagree, and this is funny. Let me close this. I would disagree and would say this was 1996. Okay, but still, in any case, this is a long time. That was 23 years ago, right? Some of you might not even have been born at the time. So, I mean, I'm an old man. So just to tell you, this month, just in a few days, I'll turn 40. Yeah, so I was born at the time, definitely, but I was not coding in Java at the time. I started coding in Java in 2001, right? So even for me, this is
what is really disappointing, I have to say, right?
Yes, yes.
So what was it? JDK 1.3?
It was JDK 1.4. I'm sorry.
1.4, okay.
Yeah, I'm a slow man. Yeah.
So already with hotspot.
Yeah. Okay. So now I brought you this image here of this computer because I want to make a little journey back in time. To like remember what a typical computer at this time was looking, right? So we had this super sexy monitor, right? And a super sexy keyboard, super sexy computer. Let's say a typical computer at the time was a Pentium with 133 megahertz and I think 8 to 32 megabytes of RAM, right? So everyone in their hands would have much faster computers today, right? So that was a very, very different time and a very different kind of speed, a different pace, right? So this we have to understand. because that was when Java 1.0 was released, and that obviously has a lot of influence on Java even today. Java was optimized for long-running processes, right? In 1996, we didn't have agile or fragile, as some might call it. So we were still developing, let's say, over months, sometimes even over years, from an idea until this idea was finally running on production, right? And also we didn't have automated testing. So again, all this shows us the pace was different, right? So the internet was a thing, yes, but many less people were surfing the internet than today. And a typical application based on Java, for example, would consume the entire server, which means the entire hardware, right? And a computer typically would also consist only of one CPU and one core only, right? So very, very different. But today, let's make a big jump now. 2019 we have now. Most of the applications are in the cloud, right? And in the cloud environment, or even just in our hands, we have gigabytes of memory. So it seems like that, memory is super cheap these days, right? But actually, if you think about this, the opposite is true, right? Memory is the most expensive resource these days because we have to share the memory and we cannot properly share the memory, obviously, right? So this is why this is so expensive, and there are several applications running in parallel. So this is why Java might appear too fat and too slow in the cloud, right? And I mean, as I said, I'm almost developing half of my life in Java, or even more than that. So I really love Java. We all love Java. That's why we are here. So we had to find for ways of how we could improve that for Java, because many companies were already moving towards Go or Node. And who likes those languages, right? So in the last 2 years, much has happened, right? So in last year, in 2018, there was first of all Micronaut coming out. Afterwards, there was GraalVM coming out. And then there was Helidon. By the way, after my session, there is just another session talking about Helidon. So I highly recommend you to stay and to also listen to that. That perfectly fits to this session here about Quarkus. And then in March 2019, only this month, Quarkus came out. So there's a lot of what we call cloud-native applications that have come out. And today I want to talk and show you Quarkus. Okay. So to better explain this, wait, let me add a pointer here, right? I have now this graphic. By the way, obviously, this is just brainwash marketing taken from the Quarkus.io website, but I think still it can help us to better explain how Quarkus is working, right? So here I have 3 different applications: Quarkus with GraalVM, second Quarkus on OpenJDK. So this would mean it would be running on as a native executable. And we'll demonstrate this very soon live. And third, we have a traditional cloud-native stack. So that could be an application, for example, on Wildfly or on Jetty. It could also be Spring Boot, right? So anything that was released most probably before 2018. Okay. So and now we want to look at 2 different things. First of all, at the memory RSS, right? So what is that? Well, very often we speak about the heap and we think that's all what matters. Well, actually, in the cloud, what we really care about is the entire memory that we are using, because that's what we're paying for, right? And that's what the memory RSS is. Okay, so, and obviously, as this is just, first of all, marketing, this is just a very simple artificial hello world example that we have here, right, to be fair. But still, I think the message still fully applies that, Quarkus running as a native executable will always be smallest, right? So in this case, just a very simple REST application would consume only 13 megabytes of RAM. And if you're running instead this traditional on the OpenJDK, on the hotspot VM, it would be 74 megabytes, so much more already. But then again, if you compare this to a traditional application, you would have almost double the amount with 140. Now, if you say, yeah, that's just REST, how about if there are more dependencies? Obviously, the more dependencies that we have, the more this will grow, right? Here's, again, probably more like an artificial example, but as I said, it can give us an idea that even when this grows, the whole stack here will grow, right? But Quarkus running as a native executable will always be fastest. Okay. So, and now you can even, by the way, this is maybe something that I should point out, native executable, right? First of all, what does this actually mean? Well, it means, when we're developing in Java, we're not thinking as a native executable. We're thinking in develop once and run everywhere, when native executable means we're developing it for a specific platform, right? And why was Java optimized for long-running processes? Because the cool thing is this can be optimized just in time, and then it's possible that this can even be running faster when it's running on the OpenJDK, on the hotspot VM, right? So why would we ever, and I want to ask this, why would we ever want to actually run something as a native executable? Well, the thing is the size, the memory size, right? Because even if once this has heated up, it might even run faster on the OpenJDK hotspot VM. The thing is, we get more for the money that we pay in the cloud. Because if our application in this case just uses 13 megabytes, we can run, compared to here, the traditional application, 10 times the applications. So the question is about how many requests can we serve for a given amount of memory, right? And here, Quarkus running as a native executable totally outperforms an application as a traditional application, right? Okay, so this is about the memory. Now let's also look at the boot and first response time. This is, by the way, might also be a bit tough. So let me explain this. So what is this actually? Boot plus first response time, right? Well, first of all, we have the boot time, right? So if you have an application, for example, like Spring Boot, in the console, you see how it's booting up. And it will give you some log info messages, and then at some point it will tell you I've started, right? And you would think this is ready. But the thing is, if this is running on a traditional JVM, it still has to heat up. And this is happening lazily when the first response, when the first request is coming in, right? And only when the first request is coming in, our JVM can heat up. And this will need additional time. So we're not speaking about the response actually, but we're speaking of this additional thing that we need for the first response, because that's what really matters, especially in a serverless environment, right? So this is here really the question, like where and which environment are you running? Are you actually already running in the cloud? And more specifically, this is really perfectly tailored for a serverless environment where you want to scale up and down really, really quickly, because some might say, I think I already got this from the audience when I gave this talk in a different location. People would say, well, 4.3 seconds as a boot plus first response time, that is super fast. Okay, well, first of all, keep in mind this might just be an artificial example. So if you have like a bigger application, it might be longer. Second, even if you have 4.3 seconds, well, might be fast for you, but in a serverless environment, if you're starting up a container, and then you're telling your users, please wait 4.3 seconds, please wait, please wait, please wait, they will be long gone, right? So 4.3 seconds is an eternity. But if we're looking here at Quarkus running on Gual VM as a native executable, it goes as low as 14 milliseconds, right? And now this is really comparable to a Go or Node application. And that's really the cool thing, right? So here we're really back in the game, okay? So, and even 75 milliseconds is super, super cool, right? Okay, so with REST and CRUD, the same thing. So I guess, I hope you got roughly the idea, right? So now what is missing is explaining you how this is actually working. But before I do so, I'll actually jump over and I want to already start with some coding on the console. Because the thing is actually, we're starting here reverse, right? Normally we would develop a program, la, 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 happy, happy. And once this is done, we're doing the ops part, and we're seeing how we can release this to production. But as this is taking a while, I want to do this in the background to create our native executable. And while this is running for, let's say, 1 or 2 minutes, I can explain you more of how this is working. And yeah, so we can use this time, and I will not have to bore you too much. Okay, so let me now copy this. By the way, keep in mind, here is the link, bit.ly JakartaOne. So I put this here so you can also copy this, and you can also run this. Maybe you want to listen now to this presentation, and also forget don't forget there is so many other cool presentations, like just after me there is Halidon. So, but maybe tomorrow, if you have time, if you have a minute, go here, copy this. So here, this is the most current version. the Quarkus Maven plugin. And yes, there is not only a Maven plugin, but also a Gradle plugin, so whatever you prefer. I'm just, as I said, an old man, so I really like Maven. I like the simplicity of Maven, and this is the version 0.21.2 that I'm using here, so that even if you watch a recording of this presentation here, you will see like how I was using this. Okay, so this is just a very artificial example. Let's copy this. Okay, and right now I said, we're starting with the ops part. Later on, we do the exact same thing, and we look into the code, and I can explain you from the code side this in more detail. Okay, so ta-da-ta. Now this is running. So you see it's building a Maven stub project, and this is done. So let's now navigate there. Quarkus minus demo, and let's look what we have. Yes. So traditional Maven project. Okay. As I said, we'll look into the details later. Now, however, I want to create a native executable. And let's also look at this here, explain this a bit. So what we do here is just the normal Maven package, plus we're using here the native profile. We will see this later in the POM. Plus, remember I told you, native means it will be a native executable. I'm doing this presentation here right now on a MacBook Pro. If I would just say Maven package -p native, that means it would create a native executable for my Mac, right? But I want to run this in the cloud, right? So I want to build this as a Docker container, and that means I want to create a Linux container instead, right? A Linux native executable, right? And this is what this parameter is for, native image Docker build true. Okay, so let me copy this. Let's paste this. And now this is approximately, as I said, taking 1 or 2 minutes. Okay, so now while this is running, and you see there's even tests being executed, I go back and I tell you the missing part of how this is actually working. Maybe I go in full screen again. If this is loading, okay. Hope you can see this again. Okay, so how this is actually working. Well, as I said, there is a Quarkus plugin existing for Maven and Gradle, and I showed you the Maven version of it. Okay. First of all, there are just the class files being created traditional-wise, right? And now the Quarkus plugin does some magic, and it creates an optimized jar. So now what kind of magic is that? How does this work? How is it creating this optimized jar for us? Okay. To understand this, let's think back. How does a traditional application server like Wildfly, for example, how does it work? You have your jar or your WAR file, right? And once you have this and you deploy this to your server, what is happening? Think about this for a moment. Well, this is unpacked, right? Inside there are many, many more files. Could be XML files, JSON files. They have to, first of all, be parsed, right? And parsing, again, is no magic. So for this, we need further classes. These classes have to be loaded. They have to be loaded in memory. A, this takes additional time. B, this takes additional memory. And now the ironic part that I never, to be honest, really understood is it will be loaded into the memory, and it will stay in the memory for the entire lifetime of our application. And that is really a big, big waste. On top, besides all of this, there is also the reflection that has to be handled. There is also the annotations that have to be handled. All of this is a long-running process, right? And just remember what I said earlier in my introduction about the time. Back then, in 1996 or whatever, this didn't matter, right? As long as it was running super, super fast. But now it does. And why? Because it does, this is why we have these new frameworks, right? So, and once this is done, you can run this optimized jar perfectly. It's just bytecode on the hotspot VM, and you're happy done. However, if you want to go one step further, depends now, are you ready or not? And do you actually need that extra performance or not, right? If you say yes, I mean, GraalVM is also a very new technology, but there are already companies like Twitter that are using that famously already on productions. So yes, that is possible. Question is your organization ready for that? If you say yes, then yes, you can run this on the Grow VM, and this will be even faster. Yeah. Okay. So now I hope I talked enough so that we can see what happened in the meantime. Okay, so build success, that is great. Oh, this was really slow, actually, interesting. Normally this is much faster, maybe because I'm talking, my machine is totally overwhelmed. Just kidding. No, I mean, just keep in mind also, A, my notebook that I'm currently using is from 2014, I think. B, obviously, we're doing this live presentation here. We're doing, there's the browser running, there's everything running. So this does take a bit of performance away. But yes, this is still, I mean, even 1 minute, no one wants to wait for 1 minute. This is just too long, at least for me. I can never wait for 1 minute. This is getting boring for me. And this is why you should remember this would be traditionally the last step, right? Okay, just because this is so long, we want to do this up front. Okay. So now we could directly run this, but we will do this later. Right now, I want to instead, let me copy this. I want to instead create this as a Docker container, and again, do this at home. Here also for you, I put how you can run this directly in Docker, which we will not do today, because instead I have Minikube installed and running, so I want to run this on Minikube instead. Okay. So as you can also see, and we will look at the files, there is source main docker file native. So there are directly provided Docker files for you that you can use. And this is exactly what we're going to do right now. Okay, so now, and there it is. Okay, great. So next step, as I said, we're skipping that. And now we can directly run our kubectl. So you would either you can run this on Minikube also locally for testing purposes, or you run this in the cloud, for example, the Oracle Cloud or whatever you're using, right? So So you see I'm running this on port 8080. Already exists. Wait a second. So Minikube delete all minus. Oh, okay. No. Minikube. No, I'm confused. Cube. CTL. Delete all. Okay, sorry for that. Okay, because I want to run fresh. So let's do this again. Okay, working. And now we expose that as a node port. Okay, exposed. And now let's see the URL. Like this, I could run a curl, but actually I decided I want to see this in the browser. Okay, so here we have the URL, and we can see this in the browser. But obviously, like in my slides, if you like, you can also directly run a curl. Okay, so let me take my American keyboard over for coding. So hello, and there we have it. Wow, hello, right? How exciting is that? But wait, it's getting better. So let me switch over. So now I want to scale up, right? And keep in mind, the point here is scaling up with Quarkus is quite easy because the containers are so small, right? So first of all, let's open another tab, right? So we see we have the Quarkus demo here running for 1 minute. It's running, okay, great. And now I want to scale this up. I'll start easy with just 3 pods. Let me switch over. And then let's see what happens. Okay, so it's already done, bam. Now try this with an older framework, right? I mean, and try this not in a super big cloud, but like in a like locally on a small notebook that I'm having here. And then let's say 12. I don't know how many I can use on this notebook. It's not so big. And there we are, right? And let's test that this is actually still working. Okay, great. And now this is the ops part of my presentation, right? Now I want to also show you the live coding part and how this is all developed. In the very end, to give you some exciting of what is coming, if time is enough, I want to connect exactly against this against this containers here that we have. So let's see. First of all, because Quarkus is more than this ops part here. They really thought also how can they make it fun to develop with Quarkus, right? And there's one thing, the Quarkus developer mode. As I said earlier, there's also Micronaut and there's Helidon. As far as I don't know Helidon too much, to be honest, but as far as I know, in Micronaut, it does not exist such a developer mode. That means we can live on the fly, we can, and I'll show this, we can start our container and we can do some live coding and we'll see the changes without having to restart anything, right? And that for JavaScript developers is just normal. For Java, this was like totally new. The question now is, however, do we want to develop in this style or not? And for me as a clean coder, to be honest, right, I would prefer we start with writing a test that is read, and then we make this test pass, and then happy when everything is perfect, we go to production, right? So the question is, do we want that? In any case, it's cool, so I want to show you, right? And it's cool for presentations because I can do some live coding and I can directly show you the result. Otherwise, this would maybe not even be possible so fast. So let me show it to you. Okay, so, and this is now what we're doing, starting from scratch. So let me open up another tab. So again, I'm using the version 0.21.2, okay? So now, again, this is a nice feature. I think Quarkus, what it really is good in is this support, this tool support. It really assists us here on the console of how we can set up a project. Now, you can say this is kind of silly. I can just create my POM. Yes, you can. So it's totally up to you if you use that or if you just from scratch create your POM, okay? So here I put com.markusbiel, okay? Oh, wait, let me restart this because actually I'm on the artifact ID. I mistyped. Okay, so again, I was a bit too fast with my fingers. So again, com.markusbiel, group ID. Yes, now this is much better. So let's say Jakarta -1, okay? 1.0 is fine. Now, we could directly create a REST resource, which I will not do because I want to do this from scratch. Okay, so now let's navigate there, JakartaOne, okay? And now let's do the same thing as before. Let's see this, but this time we're opening the project and we're looking at everything in detail from the developer perspective. Okay, so now idea, POM, XML. Idea, by the way, for me, it's the best environment for developers. Really like this. Okay, so while it's starting, so let's make this full screen. Okay. So now let's navigate here a bit and let's familiarize ourselves a bit with all of this. So here, yeah, I'm using Maven, so we have the classical traditional POM XML, right? Besides that, there is much more already out of the box. As I said before, the Docker files. First of all, the Docker file for the JVM, as well as the Docker file for native, right? This is the one that we used before. Java folder is still empty. This one I will have to fill with right now, right? Resource folder, there's the application properties that is also empty, which we will have to fill. Okay. Quarkus is also nice with testing. It provides really nice testing annotations, but for testing, yeah, who cares about testing? Well, I do, but today this would just be too much for this presentation. Okay, so now let's also look a bit here at the POM. So we have Quarkus POM, nothing new here, I guess. So we inherit all the versions. So we have REST Easy here. Okay, we have JUnit 5. You could also use JUnit 4 if you like. Rest assured, it's just for testing, not really Quarkus related. The Quarkus Maven plugin, I think we used already extensively. The Surefire plugin, so you can also run integration tests against the running Quarkus container. What else do we have here? We have the, where is it here? The profile, the native profile we used before, right? So there's really no magic. Okay, so this is the POM file. Okay, so now I guess I have done enough of talking, and let's start some coding. Okay, so what should we call this class? Well, let's just take com.MarkusBiel, and let's call this developer resource. Okay. Ta-da-ta-da-ta. Okay, and what I will do now, what I will start with now is I will kind of do the same application, this hello or hello world application that we were starting in my cluster, in my Minikube cluster. Okay, so public string hello, so that you also familiarize yourself with the code and see what before you did not see, right? Okay, so return, what can we say? Hello, JakartaOne. Okay, so, and now we need, let's say, we need a pass. Oh, by the way, oh, I forgot, I want to pass, first of all, up here also. I will call this /developers, okay. And here I want actually another pass, because we will evolve this over time. And I will make this hello as just before. And I should add pass here. Okay, so now before you get angry with me, yes, I will use get here because this is just some crazy hacking. So don't do this in production. Okay, so then I want producers here. Okay, so, oh, by the way, I didn't mention, while I'm live coding, I'm just hacking blah, 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 and you have the time to watch what I'm actually doing here, like look in the imports. Quarkus is also using a lot of microprofile, and I watched some of the presentations. We heard a lot of about Eclipse microprofile already, and obviously about Jakarta EE. I expect that you already know how Quarkus fits in this all together. So it's not totally Jakarta EE. It's not totally microprofile, but it uses a bit of that. It uses a bit of these standards, and it fits nicely in. That's why. Okay. So producers, media type, which one? This one, text plain. Okay. So fine. Now let me check this. I think it's looking good. We have a pass of developers hello, text plain, hello JakartaOne. Okay, so now, no magic. Let's just directly create a package of this, Maven package. Okay, and that's it. Let's see what happens. Okay, so wow, now it's really slow. Normally this would be much faster, but yeah, demos, live demos are always like this. But yeah, who cares? I mean, I just want to show you, like, give you the general idea. Okay, so now let's go to CD target. Let's look at this a bit also, and what I would ask you, what I would recommend you, when you have time, for example, hopefully tomorrow or whenever, do exactly the same thing, and there should be a recording available shortly, and have a look in here, the structure. Because, for example, this will help you to better understand how Quarkus is working. There is this folder wiring classes. In there, Quarkus puts these classes that are wired together, right? And you can look at them. What you can also see here, there's the lib folder, because this is related to the general strategy that Quarkus has here, right? Because Quarkus was highly optimized for running in a cloud, for running as a Docker container or a container, right? So this is why, the lib folders would contain this infrastructure code typically that we need, right? And the jar file typically contains mostly the business code that we have. And both these will change for different reasons at different time, right? And this is why this is separated, so that when we create our Docker container, and this will be layered, so that this is faster and can be cached, right? So this is one. So we don't have a big fat jar anymore here, right? Okay, so now I can just start this. I have here this runner to start this. So this is, again, nothing really special. Java jar, JakartaOne snapshot runner.jar. Okay, and it started. Now this is better in 0.71 seconds. Okay, so it's running on port 8080. Again, we could run a curl on that. I will just look at this live in my browser. So let's say localhost, there it already is, developers, and let's say hello. Okay, so not found. That is interesting. Something is possibly wrong. Let me check. This is the nature of live demos. Localhost developers, hello. Something is possibly wrong. Hello. This is kind of weird. Developers, hello, not found. Okay, well, maybe we leave this for later. So instead,
Markus, the code
yes?
is sourced with Java. This is the hint from Roman.
What?
You coded in source-Java, not in source main Java.
I coded in source. You mean that the class file is somewhere else?
Yeah.
Oh, yes. Okay, yeah. Thank you. So let me just move this. Okay, that is probably better. Thanks so much. Okay, so now, by the way, if I had started this in the Quarkus developer mode, I could. This would probably just work in time. Now, however, we have to recompile this, obviously. Let me do a clean, just in case. Maven clean package. Okay. I hope my move was not too fast. Okay, let's see how fast this is this time. Compiling. Okay, 10 seconds. It's still very slow. Seems like my notebook here with this live stream is really working hard. -L. And now let's say Java JakartaOne snapshot -runner.jar. Now I'm really having a bad luck here. Java, of course, sorry, Java jar. -jar. Okay, so now let's retry if it can find this now. Okay, yes, oh, happy, yes, much better. So now the question, however, is, what if we just, the business guys are really happy, hello JakartaOne, yeah, version 1 is live, this is so cool. Maybe now we could just, emphasize this a bit more and add just one exclamation mark. So what we have to do, well, first of all, change our tests, have a failing test, then make this test pass, change the code. First of all, also obviously stop the server, then compile everything. Hopefully this time it's not in the test folder. Hopefully this time it's in the main folder, right? So you see, yeah, and then the real application, this can take us days, right? Well, maybe or hours. And now this is where the Quarkus developer mode might come in handy, but I said, questionable. If you're working in a different style with tests, then maybe you don't even need that. But this is for you to decide. The cool thing is here, however you like to work, Quarkus does support that. And this is something that I want to show you, right? So for this, we just say Maven, compile, and then Quarkus, dev. Okay. So, and then we get a build failure because we are in the target folder. So again. Okay, Now you will see this starts slower than before, 2 seconds. But now we are in this interactive Quarkus developer mode. And let's see if everything is still working. Reload, OK. And we see there is no exclamation mark. Now, however, if we like, we just add this without restarting anything. And it should appear. And there it is. Wow. Now, the cool thing here is what is happening behind the scenes, what we are not seeing. For every change, the whole server gets restarted. And this is why this will allow us even to add classes on the fly. And this is what I'm doing right now. OK, so OK. And this part now, I think, should be clear. This was the code that, as I said earlier, we started. And now let's make this more cooler, right? Let's add a bit of a database connection here. So for this, I will need to fill my application properties. For this also, to make this even more cooler, I want to add some more dependencies. Again, I could just copy and paste them into my POM, but I want to show you another feature. And for this, I'll do another copy and paste, right? So, oh, by the way, I left this out here. This I'll leave for your homework. You can look at the memory usage with this command. OK, so first of all, here are the application properties. So you see I'm using a Postgres database that is already running in the background. Yes, developer password, cool, port 8080. And here we will have to put, this is the cluster that I'm running in the background. I just have to change the port, I guess. Yeah, because here it's running on port 3051, but everything else should be fine, I guess. OK, so let me copy this over. Bam. And let's directly change the port. This was here. Let's copy this, 351. And I hope the IP should be the same. Let's check 1990, 103. Yes, it's fine. OK. Now, what else do we need? This is what I said. You don't need that. It's just an add-on for Quarkus, but I think it's neat. It's nice to see. So let me at least demonstrate this. OK. Because there is many Quarkus extensions coming out. And I'm doing this presentation now for several months. And the speed is so fast, so even I can't keep up with this pace. So it's really worth it to run this command. And this will give you a very quick idea, like what extensions are there currently out there. OK, so let's see what's happening. OK, so now you see, when I did the first presentation for Quarkus, this was like a list, maybe half this double size here. Now we have two columns. There is so much, and this keeps growing. Flyway, Hibernate ORM, Hibernate with Panache, by the way. Yes, this I want to show you today. And there is lots of drivers for JDBC, MariaDB, Postgres. Today I'm using Postgres. There's JSONB, JSONP. So Quarkus is following a lot of standards. Yes, there is Keycloak. Yeah, so have a look at this list. This is really long. And I will pick now a few of them and want to show you. Actually, I would love to show you also fault tolerance from SmallRye, the microprofile implementation. But unfortunately, there seems to be some bug, and it's not fixed yet. I also found this on Google. Seems like it's already reported. But I think Eva today, I saw he demonstrated fault tolerance. So I think you already got the idea, because the idea later is connecting to the client. We could use fault tolerance to handle when it's not responding, right? In our case, we will now just get an exception. But that's also fine. OK, so, and this is it. In earlier versions of this presentation, I was typing all of this live, but this is really, really boring. And here you can also do this. So add extensions, and then I'm adding Quarkus Hibernate ORM Panache, Quarkus JDBC Postgres, as I said, yeah, using Postgres SQL, REST Easy JSONB, and a REST client. OK, and I have removed the fault tolerance because it was not working. OK, so yeah, this is work in progress. Question would also be, is this ready for production or not? My answer would be, it depends on how risk aware you are, blah, blah, blah. But maybe we answer this later in the questions more in detail. OK, so now let me switch over and let's actually execute this. OK, so So now we add it. This, on the console, this looks really nice here in IDE. For whatever reasons, I just get this question mark, but still it worked. It added all these dependencies. So let's see this in the POM. Okay, so enable auto import. Yes, this is what I want. So now what do we have? We have now REST EasyJSONB, we have the REST client, we have Postgres SQL, and we have Hibernate or Panache. Okay, so Panache is really a nice pragmatic way of using a Hibernate, let's say it like this. Okay, so now we need to add an entity, this time in the source main Java folder and not in test, hopefully. Okay, so, and thanks for this tip, by the way. Yeah, so let's say I call this developer my entity. Okay, so by the way, I'm just noticed that I'm missing my package folder structure. Let me quickly fix that. That is kind of weird. New Java class com Markus Biel dot developer. Okay, let's remove this one, delete, yes. And now let's also move this over here, do refactor, yes. Hopefully this should be working, okay. So I say extends. And first of all, I make this an entity. So entity, yes. Okay. And now, you know, this is the new thing now. If you know the active record pattern, this is exactly what I'm using here now, because I will say extends Panache entity. If you say, oh, I don't like this, okay, you can also use traditional the entity manager, or you can also use a repository. But I want to show you this because I think this is pretty cool and brand new, right? So let's maybe navigate here. So we have here the Panache entity class. That means we directly inherit an ID. And this again extends the Panache entity base class, which means we directly inherit all these here methods, right, that we can directly use out of the box. And that is, I think, a quite neat pragmatic approach. Okay, so now we need a few things, obviously. Let's say private string name. Okay. So I want two constructors. Okay. Another constructor. Select known. Okay. This will be used by Panache only. So let's add a comment so that the next super smart developer doesn't remove this from me. Only or used by Panache. Okay, we can make this actually private also. This is fine. And now I want a getter method. Okay, so I think now it's looking good. Okay, so now we can make use of this. For this, I want now two methods to speed this up a bit. We're already 48 minutes in time. Let's copy this. Okay, so first of all, this method will be called developers. For this, I will not need a pass because I will use this one here. And it will not use text plain, but this will be JSON. Okay, so, and this will also not be a string, but it will be a list of developer. Yes. And now my IDE wants to help me. So yes, I want the Java util list. Okay, so, and then I say return developer dot list all. That's all I need. And this is the method that I inherit, right? So I can directly use this out of the box. And now we also obviously we need a method to add developers to make this cool, because my database will start as empty. And this is the point where I will add intentionally, besides all the bugs that I already did, I will now intentionally add a bug, because I want to show you live how we can handle this with Quarkus, right? So let me see. First of all, let's call this new developer. Okay, so this will return a developer, obviously. Developer, develop. Typing is hard. Let's just pick this. Okay, so I want a pass param of name. Okay, and here I also need a pass. Let me copy this here. Let's say new name. Okay, so, and here we need to add string name. Okay, so now we need to create a developer. Oh, I forgot something that I really want to use, which is another cool feature from my IDE. I want to refactor this on the fly with a factory method, which I will call off. Okay, this is done. And now we can make use of this. Developer equals to developer of, ta-da, name, so fast. Okay. And now we can persist the developer. And once this is persisted, we can return it. Now, hopefully, you will spot the bug that I introduced. If not, don't worry, I'll show you. So as the code is here, let's try this and let's see what happens, right? So first of all, we will add a new developer. Assuming this is working, we will look that this worked. Okay, so let's go to my, sorry, this is myself, interesting. This one here, okay. Developers, and then I say new Raphael, yes, okay. So this site can't be reached. Localhost refused to connect. This is nice. Today, really, I have hell here. Oh, could it be that we didn't start? Yes. Yeah, that is too bad because I wanted to show you how we can code this live. Anyway, I will add more code, so this should be fine. Okay, let me just check that we're perfectly in the right folder. Maven compile. Quarkus colon dev. Okay. So okay, it started in 4 seconds. Now let's go back here. Let's retry. And there we have the internal server error that I wanted. And it says transaction is not active. Consider adding transactional to your method to automatically activate one. How cool is this? It directly tells us what we have to do, right? So this is the bug. So let's fix it. Let's just add a transactional here. And here again, my IDE can help me. Import class, okay. So ta-da, fixed. Let's try this again. And there we added it. Let's see if it worked. Okay, let's add another developer. New, what can we add? Obviously, we want to add Adam. Okay, so we added Adam. Okay, so here we have Raphael and Adam. Works nicely, great. So, and now, yeah, I added all this code and I wanted to show you how this is working also live. Now, however, I will add another class so I can show you, and this will be the client, right, the REST client. So let's say again, new class. Let's call this hello client. Okay, so register REST client. Actually, this is not a class, but an interface. Okay, so I'll say string hello. Okay, and again, we will need a pass. Okay, I'll make this hello. And again, I'll make this get. Don't do this at home. And again, I will say produces media type and text plain. Okay. So now I can use this. By the way, here you see microprofile, right? Okay, so private hello client, and I have to inject that, and I will say this is my REST client. Okay, and now we can make use of this, and I can on the fly, you know, the code is still running. Keep this in mind. I can now on the fly change this. I comment this out, and I will say hello client dot hello, right? And obviously we need to return something here. Return, okay. So now let's try what is happening. Developer is hello. Hello, yeah. Well, where's this coming from? Let's check this. Okay, so here we're back on the console, right? Remember, where is it? Watch. We have now here the whole cluster running. And if I find the other one, we'll just do it here. Yes, replicas. I can now scale this down to 0, right? This will take a while, but once this is done, we have an internal server error. And this is where I wanted to use the fallback implementation. Unfortunately, I cannot, but this proves that we actually really, now we have two applications running and they're communicating, and the one is a native application, right? And now let's also see how fast this is going up again. Okay, so I've scaled this up again, and now we're back again, right? And I can even, on the fly, change my code again. And with this, I've also proven that we were able to add this hello client, right? So comment this out, this in, and reload this. Hello, JakartaOne. And with this, I would want to thank you. That was my live coding presentation with some hiccups. I'm sorry. Yes, I hope you were still able to follow. Yeah, so Adam seems like Adam has gone.
Adam has gone. Tanya is here with the crew, and we're
Hi,
so
Tanya.
thankful to you for your presentation. I will invite people to jump onto the next session. And if you have any further questions for Marcus, please leave your questions in the chat, and Marcus will be, I'm sure, happy to get back to you. Thank you so much, and we'll see you in the next session.
Awesome, thanks. Great for having me, great honor. Yes, and now just shoot me your questions. I will have like 5-10 minutes time. I have to run because actually I'm here in Oslo at JavaZone, so I will have to run for the speaker dinner, but I have some time for questions. So let me now see what questions we have here. Which parts of Jakarta?
You will just have to read the questions and answer in the chat because we're moving to the next session.
Okay,
Thank you so much. Bye.
Okay. Bye, everyone.